Hi, hello friends. Welcome to the today's session. Welcome to Unacademy and welcome to my classes. In this session, we are going to discuss about the timer management, which is performed by transmission control protocol. So, what are the different types of timers which are available in TCP and how they are going to be useful in different kinds of aspects. So before entering into the session, let us all say our anthem that crack GATE and ESE with India's largest learning platform, none other than Unacademy. Get Plus subscription and access unlimited live and recorded lectures from India's topmost educators. Dear friends, Unacademy has created a wonderful platform to serve the dedicated students and providing top quality content by top quality educators. In this aspect, so I request you, all of you, join into Unacademy and get the content, top quality content from top quality educators. Dear friends, myself is Srinivasrao IS, having more than 15 years of experience in the GATE with the various subjects. I also had industry experience in the backend side, that is a database and systems side, with the relevant good certifications. Dear friends, throughout my journey of GATE, I taught in many premium academies with a high success rate. Many of my students got completed their post-graduation from India's topmost institutions like IITs, NITs, and central universities. You also can achieve just by clearing a GATE examination. So to clear the GATE examination, there is a requirement of proper training and tips and shortcuts and the guidance, do's and don'ts. These are the things are very much important, especially for competitive examination, because your competitive examination is completely negative marking concept. That's why stake your admission into an academy. Then an academy is going to give you trust that you can able to clear your examination. They are going to take care like a parenting. So utilize this opportunity. What the Unacademy is created, different kinds of programs are there to clear your competitive examination. Dear friends, according to that, there are different varieties of programs like Plus and Iconic. If you become a Plus member, then you are going to see that unrestricted access. Therefore, you can use live lessons, live classes, mock sessions, and mock test, and many other things which are there in an academy portal. And confidence build-up sessions are also running. So please join into an academy, either using a plus, and the other kind of program is Iconic. So Iconic is a 1:1 personal coach. A 1:1 personal coach. So this is one of the unique program introduced by an academy where you are going to get plus program and you're also going to get 1:1 personal training. So this is going to be very much beneficial to you so that you can able to clear all your doubts, because you're going to see that 1:1 guidance program. Friends, according to the plus, there are few kinds of subscriptions. This is however 12 months and 18 months and 24 months. So the current first and second year and third year students can opt for this, and the current fourth year students can opt for this, and the second and third year students can opt for 18-month subscription. So apart from top quality content, Unacademy is also offering concessions by using my referral code. So use my referral code and get the admission into Unacademy then you're going to get two important things. One is guidance from me, and the second one is concession. So these are the final prices when you use my referral code. Dear friends, the second kind of program is iconic, where you're going to see 1:1 personal training. So you are going to be given a coach who is going to give you the best, and you can able to interact with the particular coach member so that all your doubts can be cleared technically as well as mentally. So according to that, there are two kinds of subscriptions, 12 months and 24 months. If you use my referral code, so use my referral code, you're also going to get some concession on iconic subscription. So these are the final prices. The current second and third and first year students can opt for this super long term coaching, and fourth year students can opt for 12 months coaching. And dear friends, if you are having any queries, please reach us by filling in this form, and Unacademy is going to direct a member who can able to assist you to clear all your doubts. And Unacademy is successfully running very important classes on YouTube. Our YouTube channel is Let's Crack GATE ESE. So use our YouTube channel, subscribe our YouTube channel, hit the bell icon for latest notifications and updates, and use my referral code to get the admission into Unacademy. So if you use my code, then only I can able to share all my experiences. Otherwise, I cannot able to help you. So please use my referral code and join directly under me. Then you're going to get, apart from concession, you're going to get my guidance ship and my 17 years of career. Many of alumni students who have completed their post graduation from IITs and NITs, central universities, they are also are going to give you their experiences. So utilize my referral code and subscribe my channel. Please watch all Unacademy's lecture and my lectures too. So let us start today's session. The today's session is very advanced computer network. The last session we learned about the congestion control, very important topic. And before last class we learned about TCP flow control. So in this session we are going to discuss about what the types of the timers which are there in your transmission control protocol and how they are going to help you. So according to that, the first kind of timer is a retransmission timeout timer, and the second kind of timer is a persistent timer, and the other one is a keep alive timer. So these three timers are so very much needed, especially while transmission of your data, so from one TCP module to other TCP module. So what is a retransmission timer? So first give me a look to you what is a retransmission timeout timer so that you will understand. So here is the sender and the receiver TCP module. The sender has issued one segment, and whenever you push the segment we are going to use the timer, no doubt. This timer is timeout timer. If I get acknowledgement, because acknowledgement mandatory in your TCP, so if you get acknowledgement for the next expected byte, that is S100, and this timer is completed, we are going to raise a one more timer for the next transmit which I am going to push, that is S100. So for example, either the segment is lost or this segment is damaged, you consider, then once the timer is expired, then we are going to reset the timer and give it some time, and whatever the segment it is not been acknowledged, that we are going to retransmit. So here what I did, I performed retransmission of segment S100. Now what will happen? So how much time this timeout is going to be? This is our task. What is the value you are going to fix for your retransmission timeout timer? So maybe you are not going to get the acknowledgement. Few important things. One, either your segment is corrupted or lost, or there may be an internal delay. So whenever there is internal delay, then you may receive acknowledgement later. So whenever you receive acknowledgement later, but soon after your timer got expired, immediately this segment 100 is being transmitted. So we performed retransmission. So these are the cases when you are going to perform retransmission. So when you perform a retransmission, so how much time you are going to dedicate so that you're going to get acknowledgement for the transmitted segment. So this is based on internal delay. So naturally, the internal delay is going to be done using some default values like a 1 by 8 and a 7 by 8 or 0.9 or 0.1. Now if you look at what the retransmission timeout timer is saying, to retransmit a lost segments, TCP employs one retransmission timer that handles retransmission timeout duration and the waiting time for an acknowledgement of a segment. So if I receive acknowledgement of a segment, then I can able to reset or close the timer because already it is got acknowledged. But whenever it is not acknowledged, then you need to wait for acknowledgement just by taking your retransmission time. So how you can able to do this? You can able to do using two rules. So we can define the following rules for the retransmission timer. Number one, when TCP sends a segment in front of the sending queue, it starts the timer. When the timer expires, TCP resends the segment which is not acknowledged in front of queue and restart the timer. So these are the rules we are having. So when a segment is cumulatively acknowledged and the segments are purged from the queue, sender's queue. If queue is empty, then TCP stops the timer. Otherwise, TCP restarts the timer. So according to these four rules, the retransmission timeout timer is associated. One is whenever you are sending a segment to in front of queue. Another one is whenever TCP resends your segment which is unacknowledged. And whenever your segments are cumulatively acknowledgement, then the segments are purged from the queue. If the queue is empty, then there is no requirement of TCP timer. You can able to stop it. So how you can able to calculate retransmission timeout timer value? Retransmission timeout timer value you able to calculate using three different RTTs. One is measured RTT, the other one smoothed RTT, the other one deviated RTT. So three different RTTs are there. So what is a measured RTT? So what is RTT? First let me explain. Whenever connection is established between client and server, please understand. Whenever connection is established between client and server, they are going to exchange some segments for connection establishment. Either it may be two-way or three-way. Naturally, TCP follows nowadays three-way handshake only. Now, it is nothing but the client provides a request and the server is going to perform acknowledgement, and this request is going to take a TP time, and this request is going to take a end-to-end time. End-to-end time is nothing but TP time only. So I can come across that your RTT is a 2 into TP here. So this is how initially I am going to calculate round trip time. So round trip time is going to be calculated initially before exchanging your data segments. So round trip time is done when or at the time of connection establishment, because in TCP connection establishment is a mandatory. That we will see in next lecture, how you can able to implement three-way handshake protocol for connection establishment and connection closing. So right now we understand that at the time of establishing the connection, the RTT is going to be measured. Now you see, for example, if I am talking the client and the server, they understand that at the time of establishing the connection, they realize that our round trip time 2 into TP time something like 10 microseconds. That means this time guarantee that whenever I transmitted a segment 0 or segment 100, whatever it may be, I am going to raise a timer, and this timer is going to given some kind of a timeout value. So this timeout value depends on your 2 into TP, because I guess that at the time of connection establishment, I got the acknowledgement during a 10 ms time, 10 microseconds time. Therefore, every segment is supposed to be acknowledged just within 10 microseconds, because already it is being done at the time of connection establishment. So he is always guessed that every segment, whatever the client is sending to the other party or server is sending to the client, whatever it may be, they feel that we are going to get the acknowledgement within the pre-calculated time, that is your RTT. So my timer is set to your 2 into TP, and I am going to see that the acknowledgement is going to come within how much time? 10 microseconds time. If acknowledgement not come, then we are going to see that retransmission of your segment whenever timer got expired. So first we are going to learn, I already trained you what is a TP. TP is nothing but end-to-end time. So from one particular TCP module to another particular TCP module is end-to-end time. So like a WhatsApp, you transmitted a one message, and that is called TP. And when he say that blue ticks have come, that means what? It is being acknowledged. So it is taking a one side TP time, and other side also you are getting to be acknowledged TP time, right? So what is a measured RTT? Measured RTT is nothing but acknowledgement received time is a measured RTT. I already told you what is that. When you send acknowledgement, I am expecting for, when you send a segment, I am expecting for an acknowledgement, and this time is nothing but acknowledgement received time. or time to receive an acknowledgement. So MRTT for a segment is nothing but time required for the segment to reach the destination and acknowledge that has to be also. Several segments may be acknowledged together. The segments and their acknowledgements do not have 1:1 relationship. Especially in TCP, we are supporting cumulative acknowledgement system. What is the cumulative acknowledgement system? Whenever you send a group of segments, it can able to give you one acknowledgement, no problem, it's correct only. Or you want to give individual acknowledgement, no problem, but the segments and their acknowledgement do not have 1:1 relationship in the sense the segment can be cumulatively acknowledged. So in TCP, only one RTT measurement can be progressed at any time. Now let us see smoothed RTT. What is a smoothed RTT? It is weighted of your measured RTT. So if measured RTT is a weighted, then it is called as what? Smoothed RTT. It is based on internal delay. So here we are going to measure the internal delay in the form of alpha. So based on your internal delay, we are going to calculate your RTTS, smoothed RTT. So what is a smoothed RTT? Now I can say an equation like this: alpha dot, please understand, the smoothed RTT, the RTT M, that is nothing but measured RTT, is likely to change for each round trip time. I cannot give guarantee that because of internal delay. So smoothed RTT is preferred, which is a weighted average RTT, measurement RTT, and the previous RTTs. So what is the meaning of this point? Listen carefully. So client is sending a segment S0, and we guess that this has to be acknowledged exactly within 10 microseconds as per as our previous analogy. Perfect. It is arrived within a 10 microseconds. Now immediately I dumped another segment that is called S100, and I am waiting for acknowledgement. It's a slightly later. So I am taking, for example, 20 microseconds it takes to get the acknowledgement of the second segment. Then immediately you need to strike. TCP guess that next segment ultimately is going to be the later. Please understand. Next segment is ultimately is going to be the later, which is a greater than this value, no doubt, which is greater than your 10 microseconds because it is based on a what? Internal delay. Because of internal delay, your 10 microseconds are exceeded to 20 microseconds, and next acknowledgement may come exactly 20 microseconds or may come greater than 20 microseconds. So that's why it is a weighted average of your measured RTT and previous your RTTs. RTT smooth. So initially no value for your smoothed RTT. When you exchange the first segment, your smoothed RTTS is equal to your measured RTT only, because I already guessed. What I guess? Please understand. So when I guess that 10 microseconds is a measured RTT, then at the time of first exchange, your measured RTT, RTTM is 10 microseconds. Your smoothed RTT is also same. I am also guessing that 10 microseconds I supposed to get. If you get more than that time, then automatically your smoothed RTT is going to be changed. How it is being changed is nothing but your for next segment, your RTTS is going to be a little bit more than your previous RTTS. So how it is to be done? 1 minus alpha of your RTTS plus alpha dot your RTTM. So we are taking some weighted average of your RTTS and RTTM. So here alpha is nothing but your internal delay. Naturally, it is in between 7 by 8 of your smoothed RTT and 1 by 8 of your measured RTT. So according to that, what is the smoothed RTT value? The smoothed RTT is nothing but, as we already guessed, what is that? Alpha dot measured RTT plus 1 minus alpha dot your smoothed RTT, nothing but weighted RTT. So your alpha is nothing but, so alpha implementation is a mission to mission, it is going to be vary, but it is normally set to 1 by 8. So in other words, the smoothed RTT is calculated as 7 by 8 of your old RTT and 1 by 8 of your current RTT. So use this equation, then you are going to get a smoothed RTT. So what is a smoothed RTT, my dear friends? Your smoothed RTT is nothing but average of your measured RTT and previous smoothed RTT, which is RTTS is nothing but 1 minus alpha smoothed RTT plus alpha dot RTTM, which is nothing but 7 by 8 of your old RTTS and 1 by 8 of your current RTTM. So RTTM is nothing but measured RTT and RTTS is nothing but smoothed RTT. So come to deviated RTT. What is a deviated RTT? So most implementations do not use smoothed RTTs. So still you need to use a concept of what? Deviated RTT. What is a deviated RTT? It is based on RTT deviation is based on RTTS and RTTM. But here we are going to consider beta. So beta is also mission implement. So initial deviation, it is a mission implement. So initially no value. At the time of first exchange, your RTT deviation is nothing but your RTTM by 2. And in the next exchange, then what is going to happen? Your RTT deviation is nothing but very similar to your RTTS only. So 1 minus beta of your initial deviation plus beta into new deviation. What is a new deviation? Your new deviation is nothing but the difference between your RTTS minus RTTM. So naturally it is going to be set to 1 by 4. So dear friends, what is the final value? So 1 by 4 into RTTS minus RTTM, it is called a new deviation, and 3/4 of your previous RTT deviation. 3/4 of your previous RTT deviation. And the last one is retransmission timeout. So there are two algorithms to compute retransmission timeout. One is a basic algorithm, the other one is Jacobson algorithm. What the basic algorithm and Jacobson algorithm is saying, we will look into this. So the time from when the timer is started until when it expires is called as a timeout timer naturally. So when a host sends a segment into a TCP connection, it starts a timer and we are waiting to get acknowledged that. If the timer expires before host receive an acknowledgement for the segment, then host is going to retransmit that particular segment. We already seen. So for that, we are going to setting a what? A timeout period. So timeout should not be much larger than your round trip time. So TCP would not quickly retransmit the segment, thereby introducing significant data transfer delay into an application. So here I want to tell you one important thing. Your RTT, when you guess, it is a double of your TP. Your timeout, naturally I'm saying by default, your timeout is double of your RTT, right? So if you not receive acknowledgement during 2 into TP time, you don't worry, because your timeout period is going to be, I am taking an example as double of your RTT. So what is the meaning of this? Whenever client sent a segment to the receiver, at the time of connection establishment, they understand that the RTT is taken 10 microseconds time. Then immediately I started a timer and I pushed the segment 100, and it is to be acknowledged exactly 10 microseconds. If it not acknowledged within 10 microsecond, don't immediately retransmit the segment. You wait for a decent amount of time. How much? Up to your timeout period. Because your timer is not going to be immediately expired up to your timeout period. So once the timer is expired, then you can able to retransmit the segment. So up to this much time, I can able to wait. The other party is going to wait. If you receive acknowledgement before this time, then your segment is success. I don't mind. If you not receive within that particular time also, then I guess that either the segment is going to be lost, or the segment might be damaged, or the acknowledgement might be lost, or acknowledgement might be delayed. These are the four cases we will see that if at all there is a concept of error in the transmission, right? So till this particular point, we are going to wait. After that, we restart the timer, and whatever the segment is not acknowledged earlier, that segment we are going to push once again. So according to that, what we are going to do? So we are going to find a retransmission timeout value, which is not very longer than your RTT. It's just lesser than is equal to your double of your RTT, not that much longer. So that is the point. So timeout should not be much larger than your round trip time. So we are going to, TCP would not quickly retransmit the segment. So wait for a decent amount of time till your timer expired, then retransmit. So in order to calculate retransmission timeout period, there are two algorithms are there, basic algorithm and Jacobson algorithm. Basic algorithm is taking only alpha value into the consideration. Alpha and RTTM, measured RTT, and smoothed RTT, it is going to consider. But Jacobson algorithm is going to consider your RTTM and RTTS, smoothed RTT, an initial deviation and a new deviation we are going to consider, and estimated deviation is also going to be considered. So these are the values it is going to consider in order to find out RTO value, including your alpha. So what are the extra attributes we are taking in order to find your alpha? That means retransmission timeout value. So these are common. RTTS, RTTM and alpha is a common. Now I'm going to calculate a deviation point of time. So this deviation is going to give you somewhat not that much larger retransmission timeout like basic. So you people may have a doubt, what is the difference between basic algorithm and Jacobson algorithm? Basic algorithm is saying that the retransmission timeout period, whatever you are saying, So retransmission timeout period, whatever you are saying, that value is very larger. So that's why we do not want to keep this much larger value. So in order to avoid that problem, then Jacobson algorithm comes into the picture, and it is going to take deviation also, which is of 1 by 4 and 3 by 4 of your initial deviation and a new deviation. So Jacobson algorithm is saying that it is also going to calculate RTO value, which is smaller than, please understand, which is a smaller than basic algorithm. That's why nowadays TCP is not following basic algorithm. Right now the TCP is following Jacobson algorithm only. Okay. Now you are having a doubt how to compute RTO value, and you are having a doubt that can you provide one example on this? Yes, we will discuss one example so that you will better understand how to calculate RTTM and RTTS and timeout value using a basic and a Jacobson algorithm. Let us see basic algorithm concept. Basic algorithm is saying that alpha dot RTT measured plus 1 minus alpha dot RTT smoothed. Here alpha is nothing but 1 by 8. Therefore, your RTO is nothing but double of your RTT. Yes, double of your RTTS. Now let me give one example to you. Please understand, this example speak more. The example is RTTM I am giving as a 3.0. So for the first segment, please understand carefully. For the first segment transmission I am doing. So your RTTM at the time of connection establishment, we understand that 3.0, and RTTS also same. RTTS is equal to RTTM, which is also 3.0. So in the next transmission, that means second transmission, when you are doing for second segment, then RTTS is going to be computed using this equation. What is that equation? Alpha dot RTTM, alpha is a 1 by 8. So 1 by 8 into your RTTM 3 plus 1 minus alpha, it is nothing but 1 minus alpha, I am taking as 7 by 8 into your RTTS, which is of 3. So for the second transmission, please see the first transmission, this is the time. For the second transmission, I am keeping a more than your previous value. Please observe carefully. So 3 by 8, when you consider, it is, so your RTTS is equal to 0.375 plus 21 by 8, 2.625. If you add them, then you got 3. Okay, so this is how about second transmission. Now RTTS we got computed. Please understand carefully. Now what is the RTO value? Your RTO value here is, your RTO value exactly this particular time is double of your RTTS. So what is your RTTS is a 3. Then we are going to keep 6 is the value. This is the concept how you can able to find your RTO using basic algorithm. If you look at Jacobson algorithm, it is based on alpha dot RTTS you need to calculate, right? Alpha dot IRTM, that means RTT measure plus 1 minus alpha RTT smooth. We need to calculate initial deviation. Initial deviation is 1 by 4 by default, and the new deviation is equal to the difference between IRTT and NRTT. So IRTT is nothing but RTTM. NRTT is nothing but RTTS. Initial RTT and a new RTT, I am talking about that. Then your estimated deviation is nothing but 1 minus beta into your initial deviation plus beta into your new deviation, which is nothing but 3 by 4 of your initial deviation and 1 by 4 of your new deviation. So your retransmission value is 4 of your estimated deviation plus RTTS. So estimated deviation is nothing but DE. Now let us calculate some values here. If I am taking RTTM is equal to 3 and RTTS is equal to, for the first exchange it is 3 only. And next we want to calculate your RTTS for the next transmission. This is how about first transmission. In the second transmission, your RTTS, you got it as a 3. Now we also want to calculate your deviation. So what is your DI? So what is your new deviation? What is your estimated deviation? Then what is your RTO value? Finally, we want to compute RTO value only. So what is initial deviation? Come to the back. So your RTTD for the first exchange is RTT M by 2. Is RTT M by 2. Please listen. So for the first time, it is RTT M by 2, first exchange. Now you need to calculate a new deviation. New deviation is nothing but, so mod of your IRTT and NRTT. So it is 3 minus 3, it is nothing but 0. And your estimated deviation is nothing but 1 minus beta into initial deviation. So 1 minus beta is nothing but, here you can consider 1 by 4 is your beta value. Now therefore 3 by 4 into your initial deviation, how much it is? RTT M by 2, which is a 1.5, plus 1 by 4 into new deviation, that is a 0. So this is the value. Now your RTO is nothing but, so this is 1.125 into 4 plus RTTS, which is nothing but 3. So this estimated deviation you got is 1.125. So your RTO value is 4 into estimated deviation plus RTTS. So 1.125 into 4 plus your RTTS, it is a 7.5. This is how we are going to calculate what? RTO value according to Jacobson algorithm. Let us say I am taking an example like this. Please observe. Let RTTM is equal to 1.5 for the first segment transmission. For the first segment transmission, I got to understand that RTTM is equal to 1.5. So your RTTS is nothing but RTTM, which is of 1.5. So initially they were 0, and at the time of first exchange it is going to be done. Please recollect screenshots. What is that? So come to RTTS. Initially no value, but after first measurement your RTTS is equal to RTTM. So after first measurement your RTTS is equal to RTTM, and your RTTD is nothing but RTTM by 2, that is 0.75, and finally your RTO value is 4 into RTTD plus your smoothed RTT. So at the time of first exchange we are considering only RTTM, please understand. After first exchange, so here all the values are no values only. RTTS is equal to no value, and your RTT deviation is equal to no value. After first exchange, then we are going to see the values are going to be changed. How they going to be changed? Your RTTS is equal to RTTM, that is nothing but 1.5. Then your RTTD is equal to RTTM by 2, that is nothing but 0.75. Okay, and third, so here what is going to happen? Your retransmission timeout value, your RTO value is, according to this equation, is 4.5. Please understand, first segment got acknowledged how much time? 1.5. First exchange got acknowledged 1.5, and the second segment is, because of internal delay we are guessing that your RTO value is going to be this much. For the next exchange, then what is going to happen? We know the equations. What is that? RTTS you need to calculate separately, RTTD you need to calculate separately. So what is your RTTM? Your RTTM, let RTTM is a 2.5. Now your RTTS for the next transmissions are going to be alpha dot RTTM plus n minus alpha dot RTTS. If you give alpha value, then you consider, otherwise you consider as 1 by 8 only. So 1 by 8 of your old RTT, that is RTT measured, plus 7 by 8 of your smoothed RTT. What is the smoothed RTT you calculated? In the earlier step, the smoothed RTT is calculated as 1.5. Therefore, what is going to happen? So you are going to calculate RTTS is a 1 by 8 of 2.5 plus 7 by 8 of your 1.5. Then it is a 1.625. And what about your RTTD? Next exchange I am talking. Your RTTD is nothing but 3/4 of your initial deviation. So according to previous, your initial deviation is nothing but RTTM by 2, which is of 0.75, into 1 by 4 of your new deviation minus old deviation. That means RTTM minus RTTS. So what is the value? It is going to be 0.78. Now finally, what is your RTO value? So 4 times of your deviation plus your smoothed RTT, which is of 4.74. So first it is going to be 1.5, then second it is going to be 4.5, third it is going to be 4.74. So this is how it is to be done. Now, I want to solve one problem. So, one of your PSU question of ISRO. Alpha is equal to 0.9 and IRTT is equal to 10 microseconds, 10 milliseconds, and your acknowledgement transmission time is equal to 20 milliseconds. He is asking find RTO value. So when he asks a question like this, so your RTO value can be computed using a basic algorithm, can be computed using Jacobson algorithm. According to basic algorithm, we know the rule. What is that? Alpha dot plus 1 minus alpha dot. So what is alpha dot? Please look at alpha dot RTTM. So RTTM is nothing but measured RTT, and plus 1 minus alpha dot, your already calculated NRTT is nothing but acknowledgement time only. So it is a 20 ms because it is initial RTT. Now what is your value? So 0.9 into 10 plus 0.1 into 20. So this is going to be, so 9 plus 2 is going to be 11. Now what is your RTO value? According to this, your RTO value, according to basic algorithm, double of your smoothed RTT, RTTS. This I am calling it as what? Estimated RTT, ERTT also you can call. Double of your ERTT. So what is your ERTT is 11. So 2 into 11 is nothing but what? 22. And now this timeout value is going to be initial RTT to next segment. Clear? Now what will happen? Next segment, your initial RT is not a 10 ms. It is going to be how much? 22 only. Not 22. Your ERTT value. What is ERTT value? Here is 11. So let me give one more problem here. So alpha is equal to 0.9 and your initial round trip time, if at all he give question, do like this. So 10 microseconds and acknowledgements are arrived. Please understand. Acknowledgements are arrived 20 microseconds for the first one, 30 microseconds for the second one. He is asking find final RTO value. First step we know. What is that? RTTS I am going to find because already values are given to you. So alpha dot IRTT plus 1 minus alpha dot NRTT. So NRTT is nothing but the first acknowledgement time for the first segment, next acknowledgement time of the second segment. So it is a 0.9 into your 10 microseconds plus 0.1 into your 20 microseconds. You got how much? 11. So this 11 is going to be your IRTT. So your IRTT is 11, the previous one only. This is your ERTT, estimated RTT, also called as smoothed RTT. So IRTT is 11 and you got acknowledged how much? 30. Your acknowledgement has come at 30 microseconds. So again I am going to find your estimated RTT is nothing but 0.9 into your 11 plus 0.1 into your 30. So which is going to be 9.9 plus 3. it is 12.9. Now what is your RTO value? Now you can guess. Your RTO is double of your ERTT, latest one. So how much it is? 2 into 12.9. Your answer 25.8 roughly. So this is how about retransmission timeout timer. And the second kind of a timer is a persistent timer. So what is a persistent timer? Please guess. So persistent timer is ultimately used in silly window syndrome. So what is the meaning of silly window syndrome? It is trying to deal with zero window advertisements. So if the receiving TCP announces a zero window size, then sender and receiver both are going to be under waiting. Now I am telling you, there is a client and there is a server, and the client initially pushed or server initially pushed something like 100 bytes. If client unable to process the data, it is giving acknowledgement that 0. So when other party receives 0, which is nothing but what? He is going to be under waiting. Waiting for, because he is simply under blocking. That's the meaning. Waiting is nothing but simply is under blocking. Because you advertise, what is the value? 0 you have advertised. 0 means you are unable to process the previous 100 bytes. That's why you advertise it with 0. So immediately the other party is going to be under block. You need to wake up. So when are you going to wake up? After some time. After some time, client will give you, for example, this is S100, this is S0. Client will give you again positive acknowledgement with the same segment as 100, and this time he is advertising that I need 100 bytes. Okay, now exactly this point the other party is going to be unblocked. This is fine. This is what is the meaning of what? How you can able to implement a silly window syndrome, and how you can able to handle with the immediate acknowledgement system of silly window syndrome already we learned. Now here there is a one important situation I want to explain. So producer and consumer, nothing but sender TCP module and receiver TCP module. So producer send segment 0, which consists 0 by 2, 99 bytes, but consumer not consumed. Consumer not consumed because we know application layer of consumer is very slow. Then immediately he is giving positive acknowledgement, fine, because I received your segment 0, but none of the bytes inside are consumed. So I have not got any free space. So my free space is how much? 0. I will advertise him that 0 byte. Now immediately this guy is ultimately under block as soon as you receive 0 byte. After some time at the receiver, after some time 100 bytes are consumed. Therefore a receiver window got space of 100 bytes. Now what will happen? Again he will advertise with the same number, right? Again he will advertise with the same number to wake up him. Because of that segment you are under blocking only. As soon as you receive this, he is going to be under unblock. It's a normal situation. But here I want to provide a different situation. What is that? This segment is lost. When this segment is lost, then what will happen? Please understand carefully. So when this segment is lost, he is going to be under blocking, and the receiver is waiting for what? S100 data. S100 data segment. So it is impossible. Why impossible? Unless you give acknowledgement to other party, you have given acknowledgement. You thought that that has gone, but it's not gone, it's lost. So when it is lost, acknowledgement cannot be acknowledged. Please understand carefully. Only data segment is going to be acknowledged, but acknowledgement is not going to be acknowledged. Please remember. So receiver is waiting for S100 data indefinitely, and producer, nothing but sender, is going to be waiting indefinitely. He is expecting for wake up call because you made me into sleep. I am expecting a wake up call just by taking the segment, but the segment is lost during data transmission. So therefore, they are under indefinite waiting time. So they forms what? Deadlock. So whenever you see this kind of a situation, that whenever a 0 byte advertisement window acknowledgement is lost, that means response to your 0 byte acknowledgement, if it is lost, then sender is kept indefinite waiting and receiver is also waiting for the data, but it's a never ending process. So both are going to form a what? Deadlock. So to avoid deadlock, there is a situation called persistent timer. It is a specialized timer you cannot use normally. It is a specialized timer which is done by producer. As usually, I transmitted a segment 0 which consists of 0 byte to 99 bytes. I have a data 0 byte to 99 bytes and my window is full. Receiver window is full. When it is a full, immediately we will give acknowledgement that plus 1 to last number, and I am saying that advertising to 0. But immediately it has gone there and is under waiting after some time. So whenever you receive 0 byte advertisement window is a very clever, then persistent timer is going to be concept used. So as soon as you receive 0 byte advertisement window, you start the timer. Which timer? Persistent timer. So instead of waiting yourself into indefinitely, this persistent timer is going to be given a time. So what I guess, after some time, all bytes consumed from receiver, all bytes consumed from receiver window. Therefore, RWND got 100 bytes free space. So I will try to wake up him by advertising same segment. Because using that segment I made him sleep. Now I am giving same segment S100. This time I am advertising I need 100 bytes. If at all it is lost, I don't mind, because please understand, you are under waiting, right? Waiting for S100, and he is going to be under waiting for your next response, but your response is lost. Therefore, he is not going to wait indefinitely. So soon after persistent timer expires, because it is given some time, whenever persistent timer is expired, then sender will send a specialized segment that is called probe. It doesn't contain any data. He is releasing what? Probe segment. When he released a probe segment, as soon as the receiver receives a probe segment, he will understand that this is something happened to this acknowledgement. Then again, he is going to retransmit the set S100 once again, because that has to wake up him, and he is advertising that with 100 bytes. That's it. Now what will happen? His waiting time is got cancelled. Now he released from blocking and he is releasing S100 segment. This is the concept of persistent time. So persistent timers are deals with a silly window syndrome, and because of silly window syndrome, sometime you are going to form into a deadlock. So to break the deadlock situation, then persistent timer is going to be used, and persistent timer is a special timer. It is going to be started at the time when you receive 0 byte advertisement window, and the timer will give you an expiry time. If you not give a wake up call from the receiver, then we will send a probe segment, then to that segment received, and the receiver has to give you acknowledgement so that I am going to wake up. So let us see a few points about them. It is used in a silly window syndrome, used with the zero window advertisement segment. So if TCP announces a window size of 0, then sender is going to block until acknowledgement segment announcing that non-zero window size. If 0 byte advertisement window is lost, I already told you, then what will happen? Acknowledgement segments are not acknowledged and they are not going to be retransmitted. So TCP sending module is under waiting for non-zero segment. Receiving module is waiting for the data for next transmission that leads to deadlock. So to avoid the deadlock situation, the persistent timer is started whenever you receive 0 byte advertisement window. It starts the persistent timer, and when timer goes off, then sending TCP sends a special segment called a probe. The probe segment consists 1 byte of new data. So it has got a sequence number, but its sequence number is never acknowledged. It is a control segment. So receiver expects data, but receiver received probe segment. Please understand. Receiver is waiting for S100, but he received a probe segment. Immediately, it is a warning to the receiver that your previous segment is lost because you are not waking up me, I am in sleep. Therefore, receiver sends that non-zero, please understand, non-zero advertisement window segment. He will resend. Then what? Persistent timer is set to the value of the retransmission time. Generally, as soon as the sender module receives the segment, then he is going to wake up and transmit the data what they require. So what is the value of the persistent timer? The persistent timer value is set to the value of your retransmission time. So the last variety of timer, which is very important, keep alive timer. So keep alive timer is going to deal with the long idle connections. What is a long idle connection? For example, I started chatting with one friend. I say that hello, and he also responded with hello. Then after that, I said how are you from WhatsApp, but he is not responding. Due to many reasons, he is not responding. So again, we will ask him, are you there? Again, we will ask him, please respond. And see that we will send 1 or 2 messages. We will confirm that he is not responding means what? I need to close the connection. So that is the concept of keep alive timer. So keep alive timer is not going to keep your connection is going to be alive for a longer time. There is some time to close your connection, like your ATM transaction. For example, you got a message to your mobile that OTP. That OTP time is going to be limited. Maybe a 10 seconds, maybe a 1 minute, maybe a 5 minutes according to your application. So if you not given within a time, then the OTP is going to be expired and your connection is going to be disclosed. That's why every secure connection, especially TCP connections are secure. Every TCP connection is having some kind of idle time. If you exceed the idle time, then it is not going to tolerate. Immediately it will warn you, are you there or not? If you not respond, then immediately the previous connection is going to be closed. Again, you need to establish the connection. This is what naturally happen online transaction. So just I log into the system, but there is no response. Then automatically your session got expired. Like your ATM transactions. I put the code, but no response. Then immediately it gives that session is expired. The session expiring is nothing but what? Your connection establishment is gone. So you need to re-establish it. So how it is to be done? It is to be done using keep alive timer. So it deals with the idle period of TCP connection, deals with the long idle connections. Once idle period is exceeded, it's having a predetermined value, then connection is closed automatically. A keep alive timer is used in some implementation to prevent long idle connection between two TCPs. Okay. For example, a client opens a TCP connection to a server and transfers some data and is not responding next time onwards. Then immediately, maybe due to many reasons, it may be a crashed, it may be is busy with some other activity. So therefore, what is going to happen in this case, the connection remains open forever. This is very, very important. Because somebody is not responding, my established connection is alive. Therefore, we want to close this. So how you can able to close? Using keep alive time. So the remedy is nothing but most implementation equip a server with a keep alive timer. Each time server hears from a client no problem, it resets the timer value, and the timeout is usually 2 hours roughly if I am saying. If the server does not hear from the client after 2 hours, it sends a control segment, are you there? If you respond, I will continue the conversation. If you not respond, I will close the connection. So if there is no response after 10 probes, each of which is 75 seconds apart, then it assumes that the client is down and terminate the connection. So keep alive timer causes on-site to check other side is still here or not. So my dear friends, so these are the very important timers which are there. Like other timer is a time wait timer. Especially this is used when you disclose the connection and waiting for acknowledgement. So that we will see in the next session with the connection management in your TCP. This is exactly is being used in three-way handshake protocol. That we will see and learn this time wait timer. Okay friends, so thank you very much for your support. Please watch this lecture especially on retransmission timeout timer. Remaining two timers you may guess it. I think so. And first timer value, how to calculate RTO value using a basic algorithm. How to calculate timeout value using Jacobson algorithm. Please once revise. So we'll meet in next class, that is three-way handshake protocol. After that, we will do practice session on complete TCP so that you will better understand around 30 to 40 questions I am planning. Some are 1 mark, some are 2 mark. That may be on Sunday class. So don't miss Sunday's class. It is a completely practice session on transport layer TCP. Thank you very much. Stay tuned to Unacademy. Stay tuned to my classes.